Hello all. Today I am going to explain the measurement of directivity and gain of antenna. So the main aim of this project is to find the directivity of antenna, that is the printed Yagi and printed dipole antenna. So in this experiment we need a microwave generator. This is a microwave generator which is giving us a frequency ranging from 2 to 32 gigahertz, and another one is we need an VSWR meter and the detector, RF amplifier, that is the transmitter and the receiver antennas. So you can see the antennas are placed on the tripods. Okay, so here we'll be using two types of antennas. One is the Yagi antenna and another one is the dipole antenna. So first let us know what is the antenna. So antenna is the device which is going to provide us a planar for the printed dipole, which will be a planar version of the conventional dipole and as well as the Yagi antenna. So this antenna is a planar form of the conventional Yagi, which is commonly made up of conducting rods, are called as the tubes. That is the function of the antenna, is to transfer the guided electromagnetic energy. In the first case, that is from transmitter to the receiver, and another is the vice versa, that is from receiver to the transmitter. And to measure the radiation pattern. So practical antennas usually do not radiate uniformly in all the direction. So every antenna has its own radiation pattern, which is a graphical representation of the distribution of this radiated energy, and vice versa. It is also used to measure the far field region also. So far field region is defined as what? The region of the space where the angular field distribution of the antenna is essentially independent, and the distance from the antenna, that is the transmitter and the receiver, will be maximum. And here we will be calculating the E plane. E plane is the plane which is passing through the antenna in the direction of the beam maximum and parallel to the far field. And another one is the H plane. H plane is the plane which is passing through the direction of the beam maximum and parallel to the far field. And also we are finding the directivity of an antenna. So here the directivity of antenna is defined as the ratio of the maximum radiation intensity to the average radiation intensity. So the maximum radiation intensity is given as 4 pi divided by the omega A. Omega is the beam area, which is given as 4 pi integration of Pn theta comma pi d pi, or it is also defined as what? The small change in the E plane angle and the H plane angle. So by approximately, so the directivity is given by D is equal to 32,400 divided by delta E, theta E and delta theta H. So usually this directivity will be calculated in decibels. So to find out once we find out this D, so we can calculate the directivity in dB with the formula 10 log D. Okay, now let us move to the main procedural part. First we have to keep these two antennas, placing these antennas on the tripod. Initially we have to place them nearer to each other, and we have to set the RF level in an VSWR meter. So here the gain has to be maximum, and we have to set the range to 40 to 50 dB. And by measuring this so this is the VSWR meter where we are measuring this VSWR in dB. So here from below, the second red line what you can see is the scale for VSWR meter, where we will be observing the readings. So this is the range which is calculated in dB, which is starting from 0 to 60 dB. And this is the gain. Okay, and always this input selector should be across 200 ohms. So once the RF level is been set, then we have to take the readings of these radiations. So the transmitter, this is the transmitter antenna. So this has to be fixed one, and we have to keep this point to be 0 degree. and slowly we have to move now we have to move this receiver to the far field, keeping this transmitter constant. Okay, so once it is been moved farther, so better to take the measurement, so it has to be moved around 60 meters or 30 meters, whatever. Once it is been moved, you have to observe, or we have to take the readings at intervals of 10 degree. So now you can see here it is at 0 degree, right? Slowly we have to take the readings, slowly we have to move this point 10 degree angles, both in clockwise as well as the anti-clockwise. So when you move it to the 10 degree interval, you can observe that there is some deviation in this VSWR meter. So with these readings, we have to tabulate the columns like this. See, this is the tabular column. So angle in degree. So how much? 0 degree, from 0 to 10 degree we have moved, right? So note down the VSWR readings clockwise as well as anti-clockwise. Then we have to take the normalized values. I will let you know later. What about this? First we have to take these readings. So this is the tabular column for the dipole antenna, which is in the H plane. So you can see here the antennas which are placed horizontally here. They are placed horizontally. So this is your H plane. So if you place it vertically, once again let me show this. So remove this antenna and place it vertically. So this will give you the E plane. Okay, so both the antennas you have to change. So first you have to tabulate for the H plane, and the next part is you have to tabulate it for the E plane. Same thing. But whatever the RF level you have set initially, that should not be changed. Keeping the same RF level, you have to take the readings of these both antennas, transmitting antennas and receiving antennas, like this. So when you keep on rotating this plane, E plane or the H plane along the intervals of 10 degrees, you can see the different values of VSWR meter. Yes, once you take down the readings here, okay, so you have to take the normalized values. So whatever the values you have got over here, so you have to draw it on this graph. So this is the graph where you have all, so this is a polar plot. So whatever the readings you have taken here clockwise and anti-clockwise, plot it on this graph, and by taking an angle of a theta h and theta e, you have to write down the normalized values for these angles both in clockwise as well as the anti-clockwise. So this has to be repeated for both H plane as well as the E plane. So from this graph, so you can obtain theta h and theta e. Once you get this theta h and theta e, substitute in this formula, and finally you will get the directivity in the dB. So this is what our aim is. Our aim was to find out the directivity of an antenna, and this completes this experiment. Thank you.